All right, today we're going to deal with the third and the final lecture of chapter number 1. And the learning goals for today's lecture: introduce the unit vectors, describe vectors using unit vectors, comprehend the addition of vectors using the unit vectors, recognize the two ways of multiplying vectors. So we'll start with unit vectors. Now, in the previous lecture, we said we can deal with a vector and break the vector into components, x and y, when we dealt with that. And we dealt with the addition of vectors, either graphically, that means you measure them, or using your knowledge of trigonometry, which is Pythagoras law, or the law of cosines, or the law of sines, and you finally get to the result of adding vectors. Or you can break vectors into components, and then you add the x components, you add the y components, you can also add the z component, and you get your resultant vector that way. Today we're going to introduce in what we call unit vectors. And the definition of a unit vector: it has a magnitude equals 1, but it has no units. The vector will have units, but the unit vectors is something that you multiply to a number. It will only tell you the direction, that's all. So if you look at your x-axis here, and I want you to look at your screen, and you can make this the x-axis, and this is the y-axis. Now, perpendicular to it will be the z-axis, which will be pointing out of the screen. The way we do that, so this will be your x-axis, this will be your y-axis. So the x and y here will be your screen, okay? But what would be perpendicular to them is the z-axis, which is pointing out of the page. That's, we're only looking at the positive here. The negative will be in the opposite direction. In this case, it will be inside the page. So this is the kind of axis that you're going to use in this textbook. So in the textbook, the plane of your page is x and y. The z-axis will be either pointing out or in. Now, in some textbook or older textbook, or you may actually find them in some textbooks, they will put the x-axis this way, the y-axis this way, and the z-axis basically above. Okay. So they're making the plane, in your case, is the and above is what is the height. But this is what we're going to use here. We're going to use in the plane, x and y will be the plane of the page or your screen, and the z-axis will be either in or out, perpendicular to it. So that's one thing that you should orient yourself to. The second is we're going to define unit vectors. And for these unit vectors, we're going to put a symbol hat on the top. Usually when you have a vector, you put an arrow on the top. But when you put a hat on the top, that means we are addressing a unit vector. So along the x, we're going to use I hat. Along the y, we're going to use j hat. And along the z, we're going to use k hat. I think this is the convention in most textbooks in engineering and physics. So along the positive x-axis, the unit vector is I hat, which has a unit equal to 1, and it will be pointing to the east. If we're looking at the, if you have a page like this, there will be east, west, and will be north and south. Okay. Now the j hat will be the unit vector along the y-axis, and in this case it will be pointing up, or it will be in the north direction. And then you have the k hat, which has a unit equal to 1, and this k hat along the positive z direction will be pointing out of the page or out of the board. So the unit vector has a magnitude equal to 1. I hat is along the x, j hat is along the y, and k hat along the z. When you multiply any number with either I hat or j hat or k hat, it's not going to make the number bigger or smaller or positive or negative. It will keep it as it is. But the I hat tells me that this is along the x, the j hat tells me that this is along the y, and the k hat tells me that this is along what? Along the z axis. Now, in the last lecture, when we dealt with a vector A, we said the vector A can be broken into an x component, which we called it AX, and a y component, which we called it the y component of the vector. So when we wrote our vector, we said A is equal to AX plus AY. That's our vector. Now, we're going to express the AX now, which is this vector here, as AX I hat. And you look at the AX here, there is no vector sign on top of it. But the AX here we call the X component, and this could be positive or negative, depending on which quadrant you're in. So the value here of AX, it could be positive or negative. But the I hat here, it tells me that this is along the x direction. What is going to tell me that it is along the positive x-axis or the negative x-axis is the value of AX. And that's what we call the x component of the vector. Similarly, for the y component of the vector, it will be AY j hat. And the AY here, it could be also positive or negative, depending on which quadrant it's in, but the j hat tells me that this is along the y-axis. So now, when I want to write my vector, okay, I will write it in terms of I hat, j hat, and k hat in 3 dimensions. And these AX and AY and AZ, they will give me the X component or the Y component or the Z component. And of course, these can have positive or negative values only if you deal along any of these directions. By the I hat will be along the X, the J hat will be along the Y, and the K hat along the Z. Is this clear? Any question on these so far? So this is basically how you look at unit vectors. So now, if I have 2 vectors, I can express these vectors in terms of their units. So I have A equal to AX I hat plus AY j hat plus AZ k hat. I can add this to another vector, which is BX I hat plus BY j hat plus BZ k hat. You know that you cannot add AX to AY. You cannot do that. You cannot just add these 2 components together because I hat and j hat, you cannot just add, these are different directions. But what you can do when you're adding these 2 vectors, you can add the x components together. So it's AX, BX, I hat, and you can add the AY plus the BY, J hat, and you can add the AZ plus BZ, K hat, and this will give you your resulting vector. In the last lecture, when we talked about addition of vectors, we said you can add vectors graphically, That means you measure them to scale, and you can add them, you sketch, and then you can add them using your knowledge of trigonometry based on Pythagoras law, the law of cosines, or the law of sines. Or you can add them algebraically, where you can basically break the vector into an x and y component. But today here we say that you can write a vector in terms of I hat, j hat, and k hat, and when you add or subtract, you're only looking at the terms that have the I hat with each other, the ones that have the j hat with each other, and the ones that have the k hat with each other. An example that we have here, you have a vector d, which 6i hat plus 3j hat minus 1k hat, and of course they give you meter here. That means that's the unit, is measured in meters. E 4i hat minus 5j hat plus 8k hat. Now they ask us to find the displacement of 2d minus e. So all I have to do is basically now multiply vector d by 2, which is a scalar. So I'll get 12i hat plus 6j hat minus 2k hat. And subtract from that the vector e, which is 4i hat minus 5j hat plus 8k hat. So 12 minus 4 will give me 8i hat, 6j hat minus 5 minus 5j hat, so minus minus will give you plus 5, so you get plus 11j hat. Minus 2 minus 8 will give you minus 10k hat, and that's basically now the resultant vector. Now you can be calculating the magnitude here, and the magnitude of this vector here, r, will be the square root of rx squared plus ry squared plus rz squared. So in this case, r will be the square root of 8 squared plus 11 squared plus minus 10 squared. And that basically will give you what will give you the magnitude. Is this clear? Any questions so far? So that's basically how you handle adding, subtracting, and so on. So from now on, when you're dealing with vectors, you're going to express the vectors in terms of unit vectors. And addition and subtraction will become easier for you. And remember, like what we did in the last lecture, you decide if you have a vector in 2 dimensions, and you want to measure your angle relative to the positive x-axis. If you are in the first quadrant, that means your x component is positive, your y component is positive, you do nothing. If you are in the second quadrant, which means your x component is negative, but your y component is positive, you add 180 degrees. And if you are in the third quadrant, where your x component is negative, your y component is negative, you will add 180 degrees. If you are in the fourth quadrant, where your x component is positive, but your y component is negative, you add 380 degrees. That's when you get your resultant vector of all of these, and you want to decide on magnitude and direction. So that's when you deal with subtraction or addition of vectors. Well, later on, we'll deal with forces and velocities and accelerations and so on. And sometimes you may have to multiply these vectors together. So multiplication of vectors is different. So for example, if I give you a very simple example of 5 times 5, you can write it this way, 5.525. Or 5 multiplied 25 is 25. The dot and the x here have the same meaning. But when you deal with vectors, that's different. It's called dot product. And this one here, it's called cross product. So now, a dot product, we call it a scalar product. Why? Because the result out of dotting these two vectors, it will be a scalar quantity. And you know the difference between a scalar and a vector. So a dot multiplication here will give you a scalar quantity between vectors. But when you use the cross, which we call here a vector product, that means the result will be another vector. So if you're crossing A cross B, you will get a third vector, which is C. So right away here, the dot and the X here, they are different when you're dealing with multiplication of vectors. A dot will give you a scalar quantity, the result of multiplication of two vectors. But when you cross, the result of two vectors will be a third vector. So what is the meaning of the scalar product? So let's take two vectors, vector A and vector B. And the angle between both of them is phi. The scalar product says that I want to basically know how much of B of A, or the projection of B onto A. So now if you complete this and you make this a right angle triangle, and this angle here is 90 degrees, so this component here will be B cosine phi. Because you know that cosine phi will equal to the adjacent, which is this one here, divided by B. So that will be B cosine phi, like what we did in the last lecture. Remember what we did in the last lecture? We said if you have a vector this way and it makes an angle theta, we said that the AX is equal to A cosine phi and the AY is equal to A sine phi, or theta. Okay. So that's basically the similar way you're getting the projection of A along B. Or you can get the projection of A along B. So you dot this and you complete the right angle triangle, and along this one you will get an A cosine phi. So the scalar product is basically you want to get how much of B along A, or how much of B along how much of A along B. So the idea of the cross product, it will be A B cosine phi, or BA cosine phi. So in that sense, A dot B will equal to B dot A, which is equal to AB cosine phi. So in general, we write A cross B equals the absolute value of A, which is the magnitude of A, the absolute value of B, which is the magnitude of B, cosine phi, where phi is the angle between A and B. And we already explained to you geometrically, that means you're just getting the projection of one vector along the other vector. Now, does it matter if I dot A with B or B with A? It doesn't matter, because the end result is a scalar quantity. And you know that scalar quantity is just a magnitude. So in that sense, in the dot product, it's okay. So now, with this definition of a dot product, where I say that A dot B is equal to AB cosine phi. So it has the magnitudes between the two vectors multiplied by cosine between both of them. Now, if the angle between the two vectors between 0 and 90, you know that cosine between 0 and 90 is going to be positive. And in this case, the scalar product will be a positive value. But if the angle phi is between 90 and 180 in the second quadrant, in that case, cosine phi will be negative. And the scalar quantity will be negative. Some of you will say, how about if A or B is negative? No, A is the absolute value of the vector, is the magnitude, so it's going to be positive. And B is going to be positive. So A and B are both positives because you're just taking at the magnitude of that. What's going to make a difference is cosine, the angle between both of them. So if the angle is between 0 and 90, the cosine is positive, and that's why you get here positive. If the angle between 90 and 180, the cosine is negative, and that's why the scalar product will be negative. The special case happens when the angle between A and B is 90 degrees. And sine 90 degrees is 0, and of course the scalar product will be 0. And of course, when the two vectors are perpendicular to each other, there will be no projection of B along A, and there is no projection of A along B. If we want to go back to the argument that we did here. So you may have these scenarios where the dot product or the scalar that comes out of this, even though we say scalar, but it's not a magnitude. It could be positive, it could be negative, it could be 0. But when you're talking about magnitude of vector, it's always positive. Is this point clear? Any questions you can ask? Okay. This is basically, yes, Fatima? Go ahead.
Hi, teacher. I want to ask about the scalar product is 0.
What?
The last one, the scalar product is 0.
Yes.
You told us that sine of 90 is a 0, but why did you take it as a sine, not the cosine?
Cosine. Cosine 90 is 0. You're always looking at the cosine. If you have a calculator now, just put cosine 90 and it will give you 0.
Yeah, we took it as the rule, right? The AB cosine theta.
Yes. Yes, okay. That's what the dot product is.
Okay. Okay, thank you.
Any other questions? So now let's apply this when I have vectors, and I can write my vectors in terms of unit vectors. So if I do that, I will deal with the unit vectors. I will have to dot the unit vectors. So let's look at the case when I am dotting I hat by I hat. Dotting I hat by I hat, like the rule that we just did, A dot B is equal to AB cosine phi. That means I want to take the magnitude of I hat multiplied by the magnitude of I hat multiplied by cosine the angle between I hat and I hat. So if you look at I hat and I hat, they're parallel. That means the angle between both of them is 0. And cosine 0 is equal to 1. And the magnitude of a unit vector, that's our definition. A unit vector has a magnitude is equal to 1. So it's 1 times 1 times 1, which will give you 1. The same thing will apply for j hat dot j hat or k hat dot k hat. The result will be what? The result will be 1. But what happens if they take I dot j hat? And I know that I hat and j hat are perpendicular to each other. That means the angle between both of them is 90 degrees. So I hat, j hat, it will be the magnitude of I hat, the magnitude of j hat, cosine, the angle between both of them, and the cosine is 90 degrees, and cosine 90 degrees is 0. So I hat dot j hat will give me 0. And that will be similar if I dot I hat by k hat or j hat by k hat, you're going to get what? You're going to get 0. So when you're dotting two vectors, you know that the only terms that are going to survive is when you dot I with I, or j with j, or k with k. Any other combination will just result in 0. So for example, I'm dotting two vectors here, and A has an AX I hat plus AY j hat plus AZ k hat, dotted with BX I hat plus BY j hat plus BZ k hat. So you will take the IX I hat and you dot it in the three components here. Well, AX BX I hat dot I hat will give you 1, and that's why you have this term here. AX I hat dotted with BY j hat, well, I hat j hat will give you 0. You don't get anything. And when you dot the AX I hat with BZ k hat, well, I hat dotted with k hat will give you 0, and you don't get anything. Now you'll take the second IY j hat and you want to dot it here. It will give you 0 with the I hat. With the j hat, it will give you AY BY, and with the with the k hat, it will give you 0. When you take the AZ k hat, it will give you 0 with I hat and j hat, but it will give you AZ BZ, and that's it. It's a scalar quantity now. But these are the components. By the way, AX, it could be positive or negative. Remember what I told you about that. And it doesn't matter if you take A dot B or B dot A, that's always going to be the result. So let's take an example here. First, we'll look at a vector with magnitude, and then maybe we'll look at unit vectors. Find the scalar product of the two vectors in the figure. The magnitudes of the vector A has 4 units and B have 5 units. Now our definition, A dot B is equal to AB cosine phi. Again, A is not a component and B is not a component here. It is the magnitude of the vector, and the magnitude of the vector is always going to be positive. And the magnitude of A is 4 and the magnitude of B is 5. But now I have to multiply cosine phi, where phi is the angle between the two vectors. Now vector A makes an angle of 130 degrees relative to the positive x-axis. And vector B makes an angle of 130. And vector A makes an angle of 53 degrees, but I want the angle between both of them. So it will be 130 minus 53, and it will give me 77 degrees. Always, you look at the angle between the two vectors. And in this case, this will give you 4.5 cosine 77 degrees, and you have to calculate that. Okay. In this situation here, they give you vector A with 3 components and vector B with 3 components. Again, look at the AX here is positive, the BX here is negative. I told you this could be positive or negative. These are the components. They ask to find the angle between these vectors. Now, one way you can say I'm going to draw them and then find the angle, but if you look at the definition of the dot product, you'll find out that A dot B is equal to AB cosine phi, meaning that cosine phi here will equal to A dot B divided by AB. Now, if you take the dot product, it just will be AX BX plus AY BY plus AZ BZ. That's your dot product. And these are the magnitudes here, A and B. Now, if you look at A dot B, it will be 2 dotted with -4. It will give you -8. 3, it will give you +6. And here it will give you -1. And that will give you -3. -8, -1 is 9, +6 will give you -3. Now, I want to get A and B, and A and B are magnitudes. And when you take a magnitude, it will be the square root of AX squared plus BY squared plus BZ squared. In the case of vector A, it will be 2 squared plus 3 squared plus 1 squared, and that's square root of 14. In the case of B, it will be the square root of -4 squared plus 1 squared plus -1 squared, and that gives you square root of 21. So this is basically the magnitudes. So now cosine phi will equal to -3, which is the A dot B. The magnitude of A is square root of 14. The magnitude of B is square root of 21. Now, if I want to get phi, I take the cosine inverse of this. So phi will be cosine inverse of -3 over square root of 14, square root of 21, and that gives you an angle of 100 degrees. Is this clear? Is this clear? So that's basically how you handle dot products. You can either knowing the magnitudes of the vectors, or you can basically express them in terms of unit vectors, and you do that. That's in the case of dot product. What is the case of vector product? In the case of a dot product, we looked at the projection of B along A. Now, in the cross product, we're going to look at the perpendicular part of B along A. And if you basically want to look at this perpendicular part of B on A, well, it will be B sine phi. That one previously, this one here was B cosine phi. But in the cross product, I want the one that's perpendicular, which is B sine phi. You can either take the perpendicular of B along A. Another way, you can also look at the perpendicular of A, which will be A sine phi along what? Along B. But you have to be careful now. When I'll talk about the order later on. But that's how we look at it. So if I want to write this cross product, which is A cross B, and remember what we said about the cross product. We defined that the cross product will result in a third vector. And a vector is going to have magnitude and direction. First, we're going to deal with the magnitude. So we're going to get the magnitude of A cross B. And the magnitude of A cross B is equal to AB sine phi. In the case of a dot product, it's AB cosine phi. But here it is AB sine phi. That will give you the magnitude of the vector. But you still need what? You still need the direction of the vector. So how would you decide on the direction of the vector? Well, the definition of this cross product tells you that the vector C is perpendicular to the plane made by vectors A and B. Meaning, if you have a vector along the X and you have a vector along the Y, the result of the cross product of these vectors should be perpendicular, and in this case it will be along the Z axis. So X and Y will make a plane, but what's perpendicular to them is Z. And that's basically going to be the direction of the third vector. So how do we decide on the direction of this vector? We're going to use something that we call the right-hand rule. And the right-hand rule tells you that you're going to use the right hand, not the left hand. So make sure that you're using the right hand, not the left hand. It's very simple. Okay. All you have to do is you open your hands, okay, and the thumbs here, your fingers should point in the direction of the first vector. So in your case here, when we are dotting A and B, your hand now, your thumb should be up, parallel to your nose, and the palm of your hand is facing you. And fingers are along the A. And then you curl them into B. The thumb here will be pointing in the direction of A cross B. And in this case, you can say that this is along the positive Y direction. Now, how about if I want to cross B into A? Well, I want to put my fingers along B and then try to curl them into A. Now, if you use the same argument that I told you now, if you basically make your palm facing you and your fingers are up and you put your fingers along B and you want to curl them into A, you cannot curl them backwards. But now, if you make the back of your hand facing you and the thumb is down, now you can put your fingers along B and you can curl them into A, but your thumb will be pointing where? Will be pointing down. And in this case, it's along the negative Y. So A cross B is not going to give me the same direction as B cross A. They will have the same magnitude. Both of them, they will be AB sine phi, because the angle is the same in both cases. You look at the situation here, and you look at the situation here, it's the same. Same vector, same angle between both of them. So they will give you the same magnitude, which is AB sine phi. But what's different is the direction. Here it is positive y-axis, and here it is negative y-axis. And when we define vectors at the in the last lecture, we said, or the first lecture, we said basically that vectors are defined by a magnitude and direction. So A cross B is equal to minus B cross A. And like when we dealt with dot product, we said B dot A dot B is equal to B dot A, which is equal to AB cosine phi. So in the dot product, the order doesn't matter. But in the cross product, the order matters, because you're getting a vector. In this case, you're getting scalar quantity. Here you're getting a vector, and the vector basically has a magnitude and direction. Is this point clear? Now, since we're going to express vectors in terms of unit vectors, so we have to cross unit vectors. And we'll start in the same way. We'll cross I hat crossed with I hat. The first thing that we're going to do is basically we're going to find the magnitude of this. So the magnitude of this will be the magnitude of the first vector, which is I hat, the magnitude of the second vector, which is I hat, multiplied by sine the angle between both of them. And of course, the angle, as we discussed when we talked about that in dot product, is 0. And sine 0 is 0. Cosine 0 is 1. But sine 0 is 0. And that will give you what will give you 0. So I dot I cross I, or J cross J, or K cross K will give you what will give you 0. Meaning, in general, if you cross two vectors, or you cross a vector by itself, you'll get 0. So A cross A is 0, B cross B is 0. It's the same vector, so the angle between the vector itself is 0. And sine 0 will give you what will give you 0. Now, if you cross I into J, now when you do that, and if I want just to get the absolute value of this, it will be the absolute value of I, absolute value of J, sine phi. Now, in this case, the angle between I and J is 90 degrees. And the magnitude of I is 1, the magnitude of J hat is 1, and sine 90 is 1, and that will give you 1. So I cross J, the magnitude of I cross J will be 1. The magnitude of J cross I will be 1. The magnitude of K cross J will be 1. Okay. But I have to deal with the direction. So now, if I want to cross I into J, if now you put your hand where your thumb is pointing to your face, and your fingers are along X, and then you curl them into Y, you turn them into I, then the thumb will be facing you, which is positive, Z direction, which is the K hat. And that's why here we say that I hat cross J hat would equal to K hat. Remember, we said that A cross B equals minus B cross A. So if you cross J with I, it would be the reverse, and that's why you get here minus K. And you can go J cross K or K cross I, and you can follow this and you get some rules for this. Now, if you keep with this, what X, Y, Z, now we say here CW. CW here means counterclockwise. That means you go in the direction of how the clock moves. CW, that means in counterclockwise, in the opposite to the clock. So now, if you go I cross J, it will give you K. And J cross K will give you I. But if you go the other way, it's negative. That means you're going clockwise. So if you go clockwise, you get negative. If you go counterclockwise, you get positive. So you can remember this rule. Or there is another simple rule as well. Triangle, you put in the here I on the top, j here and k here. Now this is the opposite. If you cross I into j, you get k. That means going clockwise here. And you cross j into k, you get I, and so on. If you go counterclockwise, you get the negative. So you can either go with this one, meaning clockwise, you're going negative, counterclockwise, you're going positive, or you can do the triangle here, I in the top, and then ij, and if you go clockwise here, you're getting positive, counterclockwise will give you what? Will give you negative. And these are basically the rules of crossing two vectors, or what we call vector product. So you have two vectors here that you want to cross them together, ax I hat plus ay j hat plus az k hat crossed with bx I hat plus by j hat plus bz k hat. Now if you take the first component here, which is ax I hat, and you want to cross it into bx I hat cross I hat will give you 0. It's gone. Then you cross I hat with j hat. You're crossing I hat with j hat, it will give you I hat cross j hat will give you k hat. So it will give you ax by k hat. And then you cross the ax with bx, you will get ax bx, but you're crossing I hat with k hat, and that will give you minus j hat. And you continue this way. And then collect all the terms that have I hat, and all the terms that have j hat, and all the terms that have k hat. You will end up with the result like this, where the cx will be aybx minus azby, and this is your cy, and this is your cx. There is a quicker way in crossing these two vectors. If they're written in terms of unit vectors, you can express them in terms of a determinant. However, the first row will be I, j, k hat. And this is the row that you're going to use in getting the value of the determinant. The second row is the component of the first vector. And the third row is the component of the second vector. So if you're crossing A cross B, well, these will be the components of the A vector, and these will be the components for the B vector. Now, if you're crossing B cross A, then here you will have the components of the B vector, and in the third one here, you'll have the component of the A vector. Now, how will you evaluate this determinant? I'm sure that you all learn this when you deal with determinant. Usually, the first component is positive, the second one is negative, the third one is positive. Then you come here, this is positive, this will be negative, and this will be positive, and this will be negative, this will be positive, this will be negative, and this will be positive. Now, usually when you evaluate a determinant, you pick a row or column to evaluate it. In our case here, when you're crossing two vectors, you have to choose the first row. Don't use anything. You have to use the first row. And if you apply this rule, the first element of the row will be positive, the second one will be negative, and the third one will be positive. And when you basically do that, if you take the first element, which is I hat, and I hat will be positive, then the first thing that you're going to do is you're going to eliminate the first row and the first column. So we'll end up with AX, AZ, and BY, BZ. Now you come to the second element. It should be with a negative sign. That's for the j hat. And you're going to eliminate the first row and the second column where j exists. So we'll get ax, az, bx, bz. And that's what you have here. And then you can come to the third. It should be positive, and that's for k hat. You will eliminate the row on the column, and you will get ax, by, bx, by. Now, it's very easy to evaluate 2 by 2 determinants. You multiply ay by b z minus az by by, and that's basically how you evaluate the 2 by 2 determinant. That will be with I hat. You do that with the second 2 by 2 and the third 2 by 2, and that basically will, in this way you can evaluate the cross product. Unlike going and figuring out, well, I take the first one and I do that, and then the second component and the third component, am I going clockwise, counterclockwise? You can do that when you have few, but when you have all the components, it's most likely this is the easiest way to do that. Is this clear? Any question on this? So let's deal with some examples here. And the first example here, they give you 2 vectors. Vector A has a magnitude 6 units. Vector B has magnitude 4 units. They don't tell you what the units are, but they give you that. And they want you to find the vector product of A cross B. Now, you know one thing, that vector C is going to be perpendicular to the plane made by A and B. They tell you that A is along the x-axis and B is in the xy plane. So it's in this plane here. What's perpendicular to the xy plane is the z. So your vector is going to be along the z-axis, where the z-axis now is perpendicular to the plane of xy. But will it be positive or negative? This is where you're going to use the right hand. And if you use the right hand and you put your fingers along A and you curl them into B, the thumb will be pointing out of the page. And that's why it's going to be what? It's going to be K hat. That's mean positive. Now, if you basically get the magnitude of the cross product, it will be AB sine phi, which is 4 times 6 times sine 30, and that gives you 12. That's the magnitude. And of course, as I told you with the right hand rule, RHR, it will give you K hat. So the vector here will be 12 K hat. Is this clear? Is this clear? Okay. So always the vector will be perpendicular. If the vector is in the xy plane, then the result of the cross product will be along the z. X or minus, you have to use the right hand. If it's in the YZ plane, then the vector will be along the x. Minus or negative, you will have to use the right hand rule. If the vector is in the XZ plane, then the result of the cross product will be in the Y direction, but negative or positive, then you have to rely on what? On the right hand rule. So what we did, we basically looked at vectors, and we write vectors in terms of unit vectors, I along the x, j hat along the y, and k hat along the z. And these unit vectors have magnitude is equal to 1. And whenever you write your vector, okay, the component either ax or bx or bz could be positive or negative. Now, in this question here, they give you a vector A, and it makes an angle theta. That's any vector. Now, they give you other vectors, okay? And these vectors are having different components. So, for example, this vector here is the first quadrant because x is positive, y is positive. The second vector here, x is negative, and y is negative. Well, it is in the third quadrant, so it will be somewhere here. The C, the x is negative, but the y is positive. Well, it means it's here, so it will be the second quadrant, okay? And the D will be the x is negative and the y is negative. That means it's in the third quadrant. Now they ask here, which one makes the greatest angle relative to the positive x-axis? Right away, the greatest will be in the fourth quadrant, but I don't have anything here in the fourth quadrant. I have this one in the third, and I have this one in the third. Okay, but which one? Well, you know by definition that tan theta is equal to AY over AX. In this case here, your tan theta will equal to minus 18 over minus 24. And in this case, tan theta will equal to minus 24 over minus 18. Now, in this, you will get a bigger value. And since you are in the third quadrant, you're going to add 180 degrees. So what will give you the biggest angle or the greatest angle will be in the D, even though B and D are in the third quadrant, but the answer of tan minus 24 over minus 18 will give you a bigger angle than minus 18 over minus 24. Is this clear? In this situation here, they give you different vectors. They give you the magnitude of each vector, the angle, and they ask us what is C cross D. Well, C has a magnitude of 12. D has a magnitude of 10. And you know, when you take a dot product, C dot D will be equal to CD cosine phi. That means 12 times 10 times cosine phi. But phi has to be at the angle between both of them. Now, this angle here is 90 degrees. So this angle here will be 90 minus 53, which will be 37. And 37 plus 25 will give you 62. So here it will be 12 times 10, which is 120 meters squared, multiplied by cosine 62. So you look and you'll find that C here gives you the 120 meters squared multiplied by cosine 62 degrees. In this one here, they ask you to cross A by C. Right away, you have X and Y plane here. So if you have an XY plane, your third vector, C, is going to be along the Z axis. So it has to be a K hat. And that's why all the answers here have K hat. Okay. It will be a lot easier, then you can eliminate. But all of them are along the K hat here. However, when you are crossing two vectors, when you want to get the magnitude, okay, it is AC sine the angle between the two vectors. So let's look at A and C here. the angle between A and C, this angle should be 90 degrees here. So the angle between A and C is going to be 65 degrees. So now your cross product will be AC sine phi. Now, if you're using the right hand and you're crossing A into C, you will find your thumb will be pointing into the page, and that's why we have minus K here. Now, the magnitude of A is 8, and the magnitude of C is 12. That's why when you multiply 8 by 12, you're going to get 96 sine 65, of course, minus K hat. So that's the answer that you look for. All of them here, they have 96. And these are positive, so you eliminate them. You have C and D, which are negative. Now, when you look at C and D, you will find sine 25, but you don't have sine 25. You have sine 65. You come here and you find cosine 65. You know that the angles are complementary, right? So sine 65, it's equal to cosine 25. And that's why the right answer here is D. Now here you have two vectors, 3i plus 4j, b, 8i plus 6j, and they ask you to get A dot B. If you're dotting these two vectors together, now you know that you're going to dot I with I, so it's 3 times 8 will give you minus 24i. It will give you minus 24 because I dot I will equal to 1, and that's what you have here. And when you come to this one, it will give you 4 times 6, which is 24, and j dot j will give you 1, so the result will be what will be 0. In this question here, they ask you to get the cross product of A cross B. Well, you can do, remember the rules that either you go clockwise or counterclockwise, but you can use the rule of a determinant. So you're going to put the first row I, j, k, but you say you don't have k, so you put 0 for it. So for the first vector, 3, 4, 0, the second vector, minus 8, 6, 0. Now the first element should be positive, and that's why you have here I. Then what you do is you eliminate this with that, and you will get 4, 0, 6, 0. The second should be with negative, which is negative j. And what you're going to do is you're going to eliminate the row and the column that j is in, and you get 3, 0, and minus 8 and 0. And in the third one, it should be positive, so you get positive k hat. And what you do is you eliminate this and that. Okay. So what you get 3, 4, and minus 8 and 6. And this is what you have here. Now it's easy to get 2 by 2. 2 by 2 is 4 times 0 minus 6. That will give you 0. Here, 3 times 0 minus 8 times 0 give you 0. And here you have 3 times 6 minus 4 multiplied by minus 8. So that 3 will give you 16 minus, but 4 times minus 8 is minus 32. So it will give you plus, and you get 50 k hat. So your answer here is C. Is this clear? So that's how you handle multiplication of vectors. In this situation here, they give you vector which has I and j. They give you another vector which has k hat. And they tell you to get the A dot B. Right away, if you dot I with k, it will give you 0. you dot j with k, you'll get 0. So the answer is going to be what? Is going to be 0. Now you have the same two vectors, 3i minus 4j and 6k hat, and they ask you to cross A cross B. Now you can do it with a determinant, but probably it's a lot easier here to use your rule. So if I'm going to use the simple rule that I gave you, where you put I here, j here, and k here. So now I have I cross with k. So you're going this way, I to k. And that will give you minus j. So that will give you minus 18j. And then you're going to cross j into k. J into k, that means you go that way. So it will give you I hat. But you have a minus here. So minus times 6 will give you minus 24 I hat. So if you rearrange, it will be minus 24 I hat minus 18 j. So your answer here will be what? Will be C. Is this clear? So that's basically how you handle cross product, or you handle dot product, and that's basically the multiplication of vectors. So what we did today, we basically defined unit vectors, and how can we basically write vectors in terms of components, I hat, j hat, k hat. Again, I remind you that the ax could be positive or negative, the ay or b or whatever, it could be also positive or negative, and the z component as well could be positive or negative. But the I hat tells me it's along the x, the j hat tells me along the y, and the k hat tells me along the z axis. Now, if you add and subtract, you only concentrate on the I hat for the x components, and the j hat for the y components, and the k hat for the z components. You cannot mix I and j. Everything has to be for the I and x, j for the y, and z for the k hat. And then we talked about the two types of product: scalar product, which is A dot B, which is equal to AB cosine phi. And you also have A cross B, which basically gives you a third vector. And this is where you really have to pay attention, where we said A cross B should equal A cross B should equal to minus B cross A. That's basically what we want to do in this lecture. Is this clear? Any question on this? Is this clear? Good.